Good day, ECO235 students. We are in week 7 and we are continuing with constraint optimization. And in particular, we are focusing on production equilibrium. Now, the prescribed text comes from your textbook and it is chapter 8.3. And for knowledge enrichment purposes, you could also consult the Jacques textbook, chapter 5.5. Now, production function shows the highest output that a firm can produce for a given combination of inputs. Now, in our case, the inputs we'll use are labor and capital. So the production function relates the quantity of output to the quantity of input. And producers are faced with the decision of how to maximize output subject to some cost constraint. This also implies that producers will try to minimize costs. Now, in the long run, you would recall that both inputs are variable. So, capital is also variable. Now, since the production is a function of two variables, labor and capital, the partial derivatives, as is given over here, right? So the partial derivative of, say, output with respect to capital, it gives the rate of change of output with respect to capital, and we can call that the marginal product of capital. And similarly, the partial derivative of this output function with respect to labor, right? That gives us the rate of change of output with respect to labor, and it is called the marginal product of labor. Now, an isoquant, is a curve that represents all possible combinations of labor and capital that is going to produce the same level of output. And the slope of an isoquant is given by what is called the marginal rate of technical substitution. And it can be shown that the slope of the isoquant is given by the ratio of your marginal products. So it is the marginal product of labor divided by the marginal product of capital. Now, the firm uses these inputs, labor and capital, to produce output, but each unit of labor and capital have a cost. So the cost or the price of labor would be the wage rate, and the price of capital is the rental rate R. That's the rental rate of capital. So the labor cost and the capital cost together would give you your total input costs. And we can from that derive our total cost function or our isocost line, and it is given by this equation over here. C represents your total input costs, and this represents your labor cost. So that is how many units of labor times the payment for each unit of labor plus how many units of capital plus the payment for each unit of capital, the rental rate, and that gives you your ISO cost line. Now, if we were to rearrange it in a straight line, you would see that the slope is negative, and the slope of the isocost line is going to be given by the ratio of the input prices, namely the wage rate divided by the rental rate of capital. Now, the isocost line also gives us all the combinations of labor and capital, which can be obtained for a particular cost C. So this is the information contained by your isocost line. Now we want to optimize our objective function, and that is subject to a constraint. Hence it's called constraint optimization, and here we're dealing with production. So here we're focusing on production, as I've said, and there is a cost constraint. So a firm would want to maximize output, that being the objective function, being your production function, and it's subject to a cost constraint. Or alternatively, it could be presented as a minimization problem. So how could you minimize cost? Then that is your objective function, and you are given a particular output. So your constraint now becomes a particular output that must be produced. So for production equilibrium, it is going to occur where the ratio of your marginal products is going to be equal to the ratio of your input prices, your wage rate over your rental rate. That is where production equilibrium would occur, when those two ratios are equal. It represents that point of tangency of the two curves, where your isoquant curve touches your isocost curve at a point. And at that point, the slopes of the two curves, which we are seeing over here, would be equal at this point, or would be the same at this point. Now, graphically, it can be illustrated as such. We have capital by convention on our vertical axis, and we have labor on our horizontal axis. Our isocost line is a straight line. So where it was given in the form of C is equal to WL plus RK, it can be rearranged such that it is a straight line and capital becomes the subject of the formula. Then you will see that your slope, of course, is negative because it's downward sloping, and it is the ratio of the input prices W over R. And your isoquant here, the slope is given by your marginal rate of technical substitution, and it is the ratio of your marginal product of labor divided by your marginal product of capital. And at point E, that is where we have production equilibrium, where we have this point of tangency with your isocost and isoquant line. And K1 and L1 represents the combination of the two inputs that are used in producing a particular output that would minimize cost. So how will you be evaluated in ECO235? So you could be asked to calculate the combination of labor and capital that you saw in the previous figure that will minimize cost, C, if the firm wants to produce a certain quantity of output. So here the output would be given, Q is given. Or you could be again asked to calculate the combination of labor and capital that will maximize output subject to a cost constraint. So here C is given. So it is very important that you read very clearly what you are given. You always need to determine labor and capital, but is it based on output that has been given, or has it been subject to a cost constraint and C has been given? So here's an example. I'm going to do two examples, and then there are a couple of worked examples for you to work through on your own. So you are told that a firm uses labor and machines to produce output according to a production function. And there you can see a production function is a function of labor and capital, and it is 4L to the power of a half times K to the power of a half. So L is, of course, the number of labor units, and K is the number of machines. You're also told that the cost of labor, so your wage rate is 40, and the cost of the machinery is $10 per unit. So to derive your isocost line, what you have in order to derive it is the cost of labor, which is W, and you have the cost of capital, the rental rate, which is 10. So that is the only information you have. So your isocost line is 40L plus 10K, and it is equal to C. We were not given your total input cost. So you can rearrange it such that you have capital being the subject of the formula. And you can see now that the slope is minus 4. It is negative because your isocost line is downward sloping, but minus 4, you can also show it to be the ratio of your input prices, 40 being labor, and for machinery or equipment capital, that was 10. So 40 divided by 10 is 4, and it is negative. So it's negative W over R is minus 4 as well. Right? Okay, so I jumped ahead, but here you can see the slope of your ISO cost line was minus 4. Next, you can derive your marginal product of labor and your marginal product of capital. Now, in order to do that, you need to get your partial derivatives of your production function. So your production function was given, it was 4L to the power of a half times K to the power of half. So please, you can see that output is a function of two variables, labor and capital. So in order to get your marginal product of labor, you are going to have to get your first order partial derivative of this function with respect to labor. So you differentiate labor, but you treat capital constant. And then you do the same for your marginal product of capital. You're going to get your partial derivative of this function of output with respect to capital, treating labor constant, right? So let's quickly do your marginal product of labor. So I'm going to get my partial derivative here with respect to L. So I know that I need to bring my power down. So it will be 0.5 times 4 times L raised to the power of n minus 1. 0.5 minus 1 is going to be minus a half, but you still have k to the power of half because it's multiplicative. So that needs to stay there, right? So if we quickly skip ahead, you can see you're going to end up getting 2k to the half. K was raised to the power of half and it was positive, but remember L became 0.5 minus 1, therefore it was minus 0.5. So you can write that in the denominator from the rules of exponents, right? And then similarly, you can get your marginal product of capital. There's your production function, right? So therefore, if we get our partial derivative of this with respect to capital, we bring the 0.5 down. It's going to be multiplied by the coefficient there, which is just 1. And k is raised to the power of 0.5 minus 1. So that's k to the power of minus 0.5, which I can put in the denominator. But remember here, you now have 0.5 and you can multiply it by that 4. So you end up having 2L to the power of 0.5 and k to the power of 0.5 in the denominator, right? So there you have your marginal product of labor and marginal product of capital. So now you are told that you need to calculate the amount of labor and machines capital used to produce 40 units of output. So that tells me that output is 40, right? So that is now the constraint in the cheapest possible way. So you need to minimize cost given the factor prices. So we know production equilibrium occurs where the slope of your isoquant is tangent to your iso cost line, or where the slopes of your isoquant, which is your marginal rate of technical substitution, which is the ratio of your marginal products, is equal to the ratio of your input prices, and that is the slope of your iso cost line. So now equating this information, this portion here is your ratio of your marginal products. It can be simplified to be K over L, and your ratio of your input prices was minus 4. So of course the negatives cancel. So you have K divided by L is equal to 4. So K can simply be written as 4L, or L is going to be a quarter K. So now you're going to take your K is equal to 4L, and you're going to take Q is equal to 40, that was the output, and you're going to substitute it into the production function. Remember, you are given Q and now you have K, so therefore you can solve for L. That becomes the only unknown, and then you can of course take L is equal to 5 and substitute it in over there and determine K. And lastly, with your values for L and K, you can determine your total production cost, and that is equal to 400. I'm going to end here and continue again.